Hello, everybody. Today we're going to learn about combinatorics, a very popular chapter in maths. So, we'll start with fundamental principles of counting. Okay, let's say there is an event which can be done in five ways, and after that event, we also have to do another action which can be done in four ways. So, in how many ways can we do the whole thing? Okay, so for doing the whole thing, we need to know what is permutation and how can we solve these kind of questions. Okay, so let's say we have to make a diagram for this kind of question. So for a diagram, first we'll take an example. Let's say let's say that first we have to pick a pencil, and after that we also need to pick an eraser, right? So in how many ways can we pick first a pencil and then an eraser? And there are five pencils. Let's say them A, B, C, D, and E, and there are four erasers. Let's call them 1, 2, 3, and 4, right? So, in how many ways can you pick an eraser and pencil and then a eraser? So, let's make a diagram. To make a diagram, we'll first see all the options for picking a pencil. So, this option is for picking the A pencil, B pencil, C pencil, D pencil, and E pencil. And these four are for picking the first eraser, second eraser, third eraser, or fourth eraser. So, if we see there will be 5 into 4 is equal to 20 ways to pick a pencil and then an eraser. Let's take a smaller example. Let's say we have mm, two pencils and only three erasers. So, in how many ways can we pick a pencil and an eraser? Same question, but the numbers are different, and it will be easier to write all the examples. So it's same. The pencils are A and B. The erasers are 1, 2, and 3. Right. So we can say that the ways are: first, if you pick the pencil A and then the eraser 1, pencil A, eraser 2, pencil A, eraser 3. This will be for the pencil A. Now for the pencil B, we pick the pencil B, eraser 1, pencil 2, a pencil B, eraser 2, and pencil C, a pencil B, eraser 3. So if we see, these are 6 ways. And if we do it with the diagram way, we'll see that for the two pencils, it will be A and B, 2 ways. And for the erasers, it will be three erasers. So 1, 2, and 3. And if we multiply 2 into 3, it will be 6, which is the same answer as we did before. So we have cleared our fundamental principles of counting, which is a permutation. So let's take an example. So this one is really simple, and we have just done this kind of question. So, but the numbers are bigger. There are 25 maths books, and there are 24 chemistry books. In how many ways can we pick one maths book and one physics book? Okay, so the answer is kind of simple. Uh, we just have to multiply the number of events for these two actions. So 25 into 24. This is the number of actions for taking a maths book, and this is for physics book, which is equal to 600. And this is the answer. So this is the answer, 600. Okay, guys, let's move forward to our next question. The next question is a dice is six faced and the numbers are 1, 2, 3, 4, 5, and 6 on its faces. When two dice are thrown, what of the when two dice are thrown, what is the number of ways in which 5 comes as the sum of the two dices, and that and the second throw will result in a sum of 4 of the sum. Okay, so if you didn't understand it, it is kind of simple. So we have two dices with with 1, 2, 3, 4, 5, and 6 on its faces, and we have another dice which is the same. Okay, so there are two same dices, and when the first throw of these two dices is done, the sum of the faces on top should be 5. This is the first event, and it should be 4 in the this is the second event, right? So the number of ways when the sum of the dice's throw will be 5. We'll first start with that. Okay, let's say the sum on the first dice is in this column and second is in this column. Okay, so when on the first dice the number 1 comes, it'll be 4, 2, 3, 3, 2, and the last 4 and 1. So there will be 4 ways, right? And we'll just record this 4 ways for 5 sum, right? And we can also say that there will be how many ways for the sum of 4? 1, 3, 2, 2, and 3, 1. So only 3 ways. 3 ways. Right? So first event, 4 ways. Second event, 3 ways. Right? So in total, the answer will be 12. Okay? So this, we have done this question also, which was a good question to understand. Next, a firm is about to take on a new sales manager and a new receptionist. There are 6 applicants for the director job and 10 for that of the receptionist. In how many ways can the pair be chosen? So this is again very simple because there are 6 ways for the first event and there are 10 ways for the second event. So the answer will be 60. Okay, I'll find a good question now. Okay, we are out of questions. We'll start with a new chapter now. This is also a permutation chapter, and its name is filling places. Okay, so this mostly has questions which will be, like in how many ways can we form a four-digit number which is odd and so on. So let's, find an example. In how many different ways can three people line up at a cube, right? So uh, we'll fill up places, which is the name of this chapter. The first place is for the first person, the second place is for the second person, and third place for the third person. Now how many people can fill up this place? How many people are there? There are three people. And in the first place, any one of those three people can come. So this has three ways. Now, how many people can come in this position? Besides the person on this position, only two can come. So two ways. And in the last position, only the remaining person will come. So one way only. So when we multiply this answer, it becomes 6. So this is equal to 3 factorial. 3 into 2 into 1. So this is the basic question of filling up places. Next question. The Khanna family moved to a new district and they decide that each person will register with a different dentist. There are six dentists in the district, and we'll need to know how many ways this family can register. And there are four people in this family. Okay, so this is also a filling up places question. We can see that there is four different places of the four family members, right? On the first place, any of the six dentists can come, six ways. On the second place, it will be five dentists, four dentists, and three dentists. So the answer in this case will be 6 into 5 into 4 into 3, which will be 360. So this kind of thing where you have to create filler places. We can also call this as NPR. In the last case, we did 6 into 5 into 4 into 3, right? So this can also be written as NPR. Now in the before case, we wrote it as 6P4, which is 6 into 5 into 4 into 3. So the this is NPR, which is the formula for permutations. So whenever you find you fill up places, you can always do this formula. So we did filling up places also. Great. Some questions are, this is the questions for all the two chapters we did today. A boy has 5 pair of trousers and 6 shirts. His sister has 4 skirts and 7 tops. In who has the most choice of what to wear? Boy has 5 into 6. Sister has 4 into 7. This is 30, and this is equal to 28. So the answer will be the boy. Okay. Next question. Okay. From the digits 1, 2, 3, 4, 5, 6, and 0 also, how many numbers, 4 digit numbers, can be formed with distinct digits, with different digits? Right? So, what will be the answer? This is a filling up places question. There are 4 places for the 4 digits, right? On the first place, any of these can come. One, 2, 3, 4, 5, 6. Not 0. Why not 0? Because if 0 comes on the first place, it will be a 3 digit number only. Right? So, for the other places, these are the numbers. Sixth place. And this is a distinct digits question. So, after we did a digit in this place, we can't use that same digit in this place. So besides that digit, this also has 6 ways. Because let's say the first place has 1. So 2, 3, 4, 5, 6, or 0 can come in the second place. Third place. Third place will have any number except these two. So the answer will be 5 into 4. So it will be 6 into 6 into 5 into 4, which is equal to 720. Let me check. Yeah, so this will be the answer. So, I guess you understood all these two chapters of permutation. Okay, so this is the end of our first session of combinatorics.